Okay, the next topic is the critical depth in a non-rectangular section. From previous lecture, we focused on the trapezoid rectangular, but now if we want to apply critical depth for the non-rectangular, how can we find the solution? For example, this one, the electoral channel with the small strip of the area. This one is area dA, okay, equal to B times dA dy, okay. And we can write equation for energy equation for this section is equal to y plus alpha q square over 2ga, okay. And we find we do the next differentiate E with respect to the depth, so we got 1 plus alpha q power 2 divided by dA power 3 dA over dy, okay. In this case of this term is equal to b, okay, from this equal to b, so we can write equation that final one is alpha q power 2 bc divided by gac. You can use this equation to estimate the yc, okay. In this case is ac bc function of the yc, okay, yc. And from this we move to by the bottom first, okay. So we from the above equation we arrange that alpha q square divided by g equal to ac power 3 divided by bc. Okay, from above table we given the area and bottom width of the many section for we try the trapezoidal, so we can bring the width and the area from this to put in the equation. So we can write that the area is equal to yc okay. That is one we can solve equation, use do this equation to find the yc. But we have another method that's from figure below figure, from figure 3-8. That is a shortcut to estimate the critical depth for non-rectangular. It shows that Z trap is equal to Q times M power 3 over 2 G divided by alpha power 102, then B power 502 5 over 2. In this case is y is equal to y prime is equal to mcb y prime and Z trap is equal to substitute y in this equation. Okay, and the plot the from below we could plot the Z trap versus y prime, okay, in the figure 3-8 in below figure, okay. So we can use this figure to estimate the YC. Okay, I will show you in the next example. I don't have enough space to. Okay, we assume that example is a trapezoidal channel like this. And the depth is y, and the bottom width is 20 feet. Okay, and side slope is 1/m. Okay, and in this case we given the m is equal to 2, q is equal to 28.2 meter per second. This one is about 1000 cubic foot per second. I want to find what is critical depth for this trapezoidal. Okay, the next we have to estimate what is the area of this trapezoidal. Equal to that is area. Okay, we use two methods. The first we try form 1. Okay, this is equal to 1. So we can arrange to get what is the Q. Q is equal to pendulum function like Q, subtract this parameter, equal to 0. So in this case we this 0. 0 is equal to thousands, and G is the 2.2 power 2. The area is y20 plus 2y power 3/2, and the y b is 20 plus 4y power 1/2. In this case, again, we have to try and error to get what is the YC. YC is equal to 3. Okay, to make guess the what is the y that make the equation equal to 0. Okay, we got 3.74. That is the second method. We using figure 3-8. Okay, second method. We estimate for this the set trap. So from base equation from Q and term the 2 is the depth. Alpha is a B power 5/2, and we got about 2.8. Okay, and from figure 3.8. We can read y if the set trap is about 2.28, so it's about this point. Come on, not clear. So we can read from the curve that this one, because what we got from the y prime is equal to 2.3 power 1.37. So we got y prime is equal to myc and b. In this case, we can estimate what is the yc is equal to the width and divided by 2 to the depth time width and divided by depth. Time width divided by slope m. Okay, because we got almost the same as the previous method, the first method, 3.7 foot.